Hello friends, welcome to the video lecture series on digital image processing. I am Dr. Dafda, and in this 64th video class of DIP, we will study the introduction to image representation and description, or you can say preview of image representation and description. Starting with the name, what is the meaning of representation? Representation means to show something, right? And what is the meaning of description? Description means to explain. So in this chapter, we will learn how to show some object from an image and also how to describe that object. Okay. So image representation and description is the next step after image segmentation, and this chapter comes under high level image processing. Let us understand with one simple example. Say this is our image and our aim is to recognize the vehicle number plate. Okay, so this is an example of vehicle number plate recognition. So what we will do, first we will do image segmentation and we will find out the borders of this car, right? So based on the edge or boundary, we can represent that this is the car in the image. Okay. And based on this representation, we find out that this is the number plate of the car. So description means based on area, shape, texture, etc. we conclude that this is a number plate with characters. And now after that, if we further go into the details that which characters are present, then that is known as object recognition. That will be your next chapter. I hope it is clear. Let us start. Starting with a slide that we saw in the very first video class, namely what is digital image processing. Here we understood that there are three levels of image processing: low level, mid level and high level image processing. Low level image processing includes some primitive operations, for example image enhancement using histogram equalization. So this we have already learned in chapters like digital image fundamentals, intensity transformations and spatial filtering, filtering in frequency domain, image restoration and reconstruction, color image processing, etc. Second one is the mid level image processing, where the inputs are images but output are attributes of images, for example edges of image. And this mid level image processing we have learned in chapters like morphological image processing and image segmentation. And now in image representation and description, as well as the next chapter, that is object recognition, we are learning high level image processing, which involves making sense of recognized objects and performing functions associated with visions. And the example we have already understood, like automatic character recognition or automatic number plate recognition. Okay, let's go ahead. This is the slide that we saw in our 48th video class of DIP, namely image segmentation fundamentals and digital image processing. So here we understood that fundamentally there are two kinds of approaches for image segmentation, that is discontinuity based and similarity based. Discontinuity based means we are finding the edges or differences, and similarity based technique means we are finding similar pixels. For representation and description also, we are considering external characteristics such as edges or discontinuities and internal characteristics, that is similar pixel values. And remember, image segmentation is the previous part before representation and description. That means after an image is segmented into regions, the regions are represented and described in a suitable form for computer processing. The region representation can be done in terms of its external characteristics, that is boundaries, and in terms of its internal characteristics such as pixel values. For example, a region might be represented by the length of its boundary. So external representations are used when the focus is on the shape of the region, and internal representations are used when the focus is on the color and texture. And remember, this representation should be insensitive to rotation and translation. Similarly, region description can be boundary descriptors such as boundary length, diameter, curvature, etc. and regional descriptors such as area, perimeter, compactness, mean value, etc. Generally, an external representation is chosen when a primary focus is on the shape characteristics, for example the shape of the car, okay, and an internal representation is selected when the primary focus is on the reflectivity properties such as color or texture, for example the number plate of the car. So in representation, we make a decision whether the data should be represented as a boundary or as a complete region, and it almost always follows the output of a segmented stage. Boundary representation is one where the focus is on external shape characteristics such as corners and inflections, and region representation is one where the focus is on internal properties such as texture or skeleton shape. But this choosing of representation is only the part of the solution for transforming raw data into a suitable form for subsequent computer processing, mainly recognition, right? So for recognizing the number plate of the car, we have to select the number plate itself, and that is done using description. So description is also called feature selection, and it deals with extracting attributes that result in some information of interest. And once the representation and the description is done, we can go ahead for character recognition. And this is the slide that we saw in 51st video class of DIP, namely thresholding, global and adaptive in digital image processing and its implementation in MATLAB. In this topic of image segmentation, we understood that if this is the original image, using multiple thresholding, that is thresholding the pixel values into black, gray and white, we can segment these coins. So using representation, we can represent that these are the coins, but using description, we can describe that these coins are bigger coins, whereas these coins are smaller coins. And if we want to further classify or identify exactly what value these coins are, we have to go for object recognition. Okay, so that is all for this video class. Thank you very much.